Hello. In this video, I'm going to teach you how to differentiate an integral on the HP prime calculator. Yes, that's right, how to differentiate an integral. So, I'm going to open my expression here, and during your engineering course, you might encounter an expression similar to this one, a derivative of an integral. So my expression is the d by dt of the integral of x to the minus 2 dx, and it's a definite integral. The initial position is t, the final position is 2t. If you're an engineering student, stick with me until the end of this video, and I'm sure you'll understand and find it super easy. Let's go. So there are three different ways I can approach this using the HP prime calculator. Let's take a moment to revisit the original problem statement. What do you all think should be performed first in this situation? Should we solve the derivative or should we solve the integral, right? That's the very first question that comes to mind when you look at this mathematical expression. So initially, the correct approach is to perform the integral, and then you will derive the solution that you obtained from that integral. Alright, let's get started. I can do it in the following way. I come here to the mathematical model button and I'll write my integral here. My initial position is t, bit par. My final position is 2t. The integral is x raised to the power of minus 2. Please note that I use this specific key right here, you see, to input the negative exponent. Alright, so this is a key where I can input any power, any exponent I might need. So, alright then, let's go ahead and proceed. I am currently working with x raised to the power of minus 2 dx. And also notice that when I'm in the function, I can input the x using this key here. See, that's the key I just pressed, so I can input x, okay? Let's go. So once my statement is written, I simply command press enter, press enter. Now I'll come here to the toolbox and I'll place it here. Next, I'm going to execute this command. I'll copy it into the parentheses, then a comma, the derivative with respect to t, and then I'll press enter. And now I can return to the toolbox, specifically to the simplify option. And then press the OK button. And here is my final result. I can also solve this problem in a different way. I can come over here. I can come here to the toolbox, differential calculus, and then on the mathematical model button, I can write my integral from t to 2t, and here I'll write x to the power of minus 2 dx. Look, here's the secret to solve this statement. I'm going to place the cursor forward, I'll type comma, and my derivative in t, then I'll hit enter. I hit enter, and there's my sentence. I go to simplify, I copy it, and I've got my answer right there on the calculator screen. Or I can also choose to solve this in a completely different way. I can come over here, you see, and just write out this sentence. We'll come here to the mathematical model button, and I'll write it like this. The derivative of the final position, the integral of 2t dt, which then multiplies parentheses. I'll exit the parentheses here and put squared, or rather 1 minus 2, right? The power of negative 2. That is the power that is on x inside the integral. Now I go inside the parentheses and I place again the final position of the integral 2t minus, now here, the mathematical model's key, derivative, initial position is t, derivative with respect to t, which multiplies. Again, in this parentheses, I'm going to place my power, minus 2, which is the power that's accompanying the x inside the integral. And here I'll put the initial position, which is t. Man, am I going crazy? Will this even work out? Huh? What do you all think? There it is, right here. You see? Now I'm going to simplify. And there's my answer. So what did I use here? I used, Leibniz's one-dimensional theorem. This shows that Leibniz was a mathematical genius, just like Newton. Did you like this video? If you did, leave a like, follow my channel, and hit the bell for more demonstrations of the HP Prime calculator's use with a focus on engineering. Take care, everyone. Bye.